Yeah, hi friends. So in this, I'm going to talk about how do you create an operator with the Go and the Kube builder, and what this is about. So beyond container orchestration, that's the topic of this. So okay, let's go about how it happens. So what happens in the container orchestration? So you have a compute, you have a network, you have a storage, you have a K8s, and then you have pods and apps. So K8 is like a Kubernetes. So Kubernetes is not just a platform, it is a standardized operating system. It provides a universal API, states caching, and a control loop to manage any external infrastructure as code. So now you have a Kubernetes universal router, and with that, you can have an AI workload, edge devices, AWS EC2 instances, and external databases also connected through. Now, a time comes when we need controllers, and this could potentially falls into two ways. So you have a native controllers, and then you have a custom controller. So what are the native controllers? So these are built in like pods, services, secrets, firecodes. They have the universal domain logic, which is like about how do you do scheduling and writer, and it has like some system boundaries, like it is inside the local Kubernetes cluster. Now you need to have some custom operators. So these custom resources, you have an EC2 instance, MySQL DB, then highly specialized AWS instances, DB backup. Then the system boundary is like they need to reach out to the external APIs and cloud providers. So an operator is simply a native controller bundled with a domain specific knowledge of the outside world. So let's come with one query. So you type kubectl get EC2 instance. You go to the API server. The server does not have a resource type EC2 instance. So you do a make install. You do custom resource definition. Then you have an API server with a group within and a kind. So now the server accepts the custom YML persisting the user's desired state into an etcd without yet knowing how to build it. So now what is the anatomy of a custom resource? You have a type metadata, which is kind of an API routing identity. You have an object meta, Kubernetes meta, and RBAC scope. You have a specification, which is a desired state, the strict developer request. You have a status, which is the actual state, the absolute truth, populated by operator from AWS. Now, what is the core engine? The core engine is like you act, you observe, you have a path A and a path B, then you compare. So basically, that's the act, observe, and a compare. So in act, you are creating, you are updating, and you're deleting. In observe, you have a reading specification plus status, and then compare, you are detecting the drift. The happy path is exit gracefully, zero API calls made. So the golden rule, an operator must be idempotent. Running the loop 100 times on a match state must result in zero external changes. So under the hood, how the reconciliations, API server update event plus YML object, it goes to an informer, which is your local cache. It has an event handler which extracts the namespace and a name, and then you have a working queue which is does the deduplication, so prevent storming, and then you have a worker which do the reconciling. Then it safely reads full YML by passing the API server. Now let's see how can we do bootstrapping with Kube Builder. So you go to the main.go manager, the phone book scheme registers native resources plus EC2 instance CRD. Then you goes to the communicator, which is like a cache Kubernetes client. Then you have the controller, which does the controlling part. So Kube Builder auto generates the manager to handle the active passive high availability, leader election, local caching, and API server communication, isolating the developer to focus entirely on reconcile logic. Bridging the gap, the AWS Go SDK. You have a Kubernetes and a Go operator. The operator formats etc instance.spec into an AWS run instance input struct. Then you have a AWS cloud boundary where AWS API processes run instance returns a private IPT, but the status is pending. The bottleneck, new instance running waiter. So the waiter execute exponential backup polling max 3 minutes until AWS confirms state is running. When the AWS confirms running, operator execute describe instances to fetch the newly designed public IP. So now let's see what is a reconcile return matrix. So when you have a return code, return ctrl.result error not nil kb, it ignores the queue request and triggers self-healing by an exponential vector. When you return requeue after 10 seconds, it's like a cron job, which is a continuous polling useful to deduction. When you return true, it's an immediate requeue with exponential weckoff. When it's an empty, it leaves securely. Wait for the informator to detect a user request. So the kind of what is the infinite loop trap that can happen? So you have a reconciler create EC2 instance reconciler update the object status with the new instance ID, creates API server detects object modification, API server generates a new update event, then the reconcile trigger again disaster, ignore it, reconcile spec creates another instance, warning updating an object in your code count at a resource modifier. It will immediately re-trigger your own reconcilier. So don't try to update an object, right? So how do you make it idempotency? Basically, you do not just let it go. So basically what you do, whenever the reconcilier gets triggered, it checks the object status instance ID. If it is true populated, object already exists, action return null, it halts. If it is false, new request deducted, proceed to the AWS API, create instance, update status and prepare to halt the inevitable next loop. The operator must inherently distrust the current execution and rely purely on the recorded state in the status block. Safely deleting external resources. Phase 1, users run kubectl delete EC2 instance. Phase 2, the creates apply a deletion timestamp but specifically blocks removal because the finalized string exists, YML still remain. Phase 3, reconciler deducts deletion timestamp not equal to 0, calls AWS SDK terminate instance and invoke the terminated waiter. The phase 4, the unlock, the AWS confirms termination, reconciler explicitly removes the final string, key it instantly deletes the YML. Productizing the operator namespace EC2 operator system. You have a port 8080 Prometheus matrix. You have operator pod port 81 K8 liveness and readiness prop. You have a bridge list get watch update. Then have a names of billing team EC2 incident deployment. The master semantic. So user YML applied. You have a control plane, API server, informer, cache, walking queue. Then you have operator brain, which is called reconcile triggers, idempotency check. Then you have a result matrix. Then you have a cloud boundary, AWS Go SDK, run instances, better loop, describe instances. So it writes to the create status, finalize, log applied, matrix exposed to Prometheus. From container orchestration to universal cloud, you now have the blueprint. Thank you.